The delayed choice quantum eraser is a pivotal experiment in quantum mechanics that highlights the complex relationship between observation and the behavior of quantum particles, specifically regarding wave-particle duality. Initially proposed as a thought experiment by physicist John Archibald Wheeler in 1978, the experiment demonstrates that the choice of measurement can retroactively influence a particle's behavior, raising profound questions about causality and the nature of time itself. This paradox challenges classical intuitions and suggests that particles do not possess definite properties until observed, compelling physicists and philosophers alike to re-evaluate foundational concepts in both science and metaphysics. At the heart of the delayed choice quantum eraser experiment is a setup involving entangled photon pairs. One photon is directed toward a double slit apparatus, while its entangled partner is sent to a separate detector. The experiment reveals that if The experiment reveals that if the which path information is erased after the photon has passed through the slits, an interference pattern can still emerge, indicating that the act of measurement fundamentally alters the state of the quantum system. This outcome suggests a nonlinear view of time, where future choices can seemingly affect past events, prompting extensive debate and diverse interpretations regarding the implications of such findings for our understanding of reality. The delayed choice quantum eraser has been subject to various criticism, particularly concerning its implication for backward causation, the notion that future events can influence the past. Detractors argue that this challenges the traditional linear conception of time and raises potential logical inconsistencies in causal relationships. Despite these controversies, the experiment remains a crucial area of inquiry in quantum physics as it delves into the very nature of reality, measurement, and the philosophical implications of quantum mechanics, inviting ongoing research and discussion in both scientific and philosophical circles. The delayed choice quantum eraser experiment is a significant illustration in the realm of quantum mechanics that explores the nature of wave-particle duality and the role of observation in determining the behavior of quantum particles. The core concept is derived from the principle that the choice of how to observe a quantum system can influence the system's past behavior, suggesting that the act of measurement plays a crucial role in shaping reality. This paradox challenges classical intuitions about causality and time. The foundational setup of the experiment involves a beam splitter and entangled photon pairs, where one photon is directed toward a double slit apparatus while the other is sent to a separate detector. In typical scenarios, when a measurement is made, the particle behaves like a wave, creating an interference pattern. However, if the measurement is altered post-incident, effectively delaying the choice of measurement, researchers find that the interference pattern can still be observed despite the fact that the measurement was made after the photon had passed through the slit. This effect, known as the quantum eraser phenomenon, posits that by erasing which path information after the photons have been detected, the interference pattern can be restored, thereby raising questions about the nature of reality and the relationship between observation and quantum states. This indicates that particles do not possess definitive properties until measured, a concept that has led to extensive discussions and interpretations within the quantum mechanics community. The philosophical implications of the delayed choice quantum eraser resonate with long-standing debates about the nature of time and causality. It supports a view that time may not be linear in the way we intuitively perceive, and suggests a more complex interaction between observation and the unfolding of events in the quantum realm. As researchers continue to explore these ideas, the delayed choice quantum eraser remains a pivotal experiment in understanding the fundamental principles of quantum physics. The delayed choice experiment is a thought experiment proposed by physicist John Archibald Wheeler in 1978, which explores the nature of quantum mechanics and the implications of measurement on the behavior of light. The core idea of the experiment revolves around whether a choice made after a photon has passed through a double-slit apparatus can influence its behavior as a wave or a particle. This seemingly paradoxical situation raises questions about causality and the nature of time in quantum mechanics. The central premise of the delayed choice experiment suggests that a decision made by the experimenter regarding whether or not to observe the witch part information of a photon can retroactively determine how that photon behaved in the past, whether as a particle or a wave. This has led to interpretations that challenge classical notions of causality, suggesting that actions taken in the present can influence events in the past. The thought experiment highlights that if the apparatus is arranged to observe which slit the photon passes through, the interference pattern typically associated with wave behavior disappears. Conversely, if the apparatus is configured to erase this information after the photon has already passed through the slits, the interference pattern reappears, leading to the conclusion that the act of measurement plays a critical role in determining the state of the photon. Although initially treated as a philosophical inquiry, the delayed choice experiment found empirical support in subsequent experiments conducted in the 1980s. The first experimental demonstration was carried out by Carol Alley, Oleg Jakubowicz, and William Wicks at the University of Maryland, which confirmed Wheeler's hypothesis that the choice of measurement could appear to retroactively affect the behavior of photons. Subsequent experiments further refine these findings, reinforcing the idea that the outcome is not determined until the final measurement is made. These experiments were instrumental in illustrating the failure of classical intuitions in explaining quantum phenomena, emphasizing the need for a deeper understanding of quantum mechanics. They have led to ongoing debates regarding the implications of such results on our understanding of time, causality, and the nature of reality itself. Despite the intriguing implications of the delayed choice experiments, many misconceptions persist. It is important to clarify that the experiment does not imply that the past can be rewritten in a literal sense. Rather, it illustrates the complexity of correlation and causation within quantum mechanics. Observers often mistake the correlation between choice and observed outcomes as evidence for retrocausality, while in reality it underscores the intricacy of quantum measurements and the interpretation of results in the context of wave-particle duality. The delayed choice quantum eraser experiment serves as a compelling example of the non-intuitive nature of quantum mechanics and the necessity of re-evaluating our understanding of fundamental concepts such as time and causality in light of experimental evidence. The delayed choice quantum eraser experiment illustrates fundamental principles of quantum mechanics, specifically the interplay between entanglement and interference. At its core, this experiment demonstrates that the behavior of quantum particles, such as photons, can be influenced by the availability of witch path information even after they have been detected. The quantum eraser involves a sophisticated setup that includes down converters, which are devices that take a single photon and convert it into two entangled photons with lower energy. One photon, known as the signal photon, follows a path towards a direct detector, while the other, called the idler photon, is directed elsewhere. The key feature of the quantum eraser is that the signal photon's path can be determined through measurements of the idler photon. If which path information is accessible, the result is the suppression of interference patterns. However, if this information is erased, the interference can be restored. Entanglement plays a crucial role in a quantum eraser's operation. In an entangled state, the properties of the two photons are correlated, allowing for quantum effects to be observed over distances. The act of measuring one photon can instantaneously affect the state of the other, regardless of the distance separating them. This non-locality is a hallmark of quantum mechanics emphasizing that observation can retroactively influence a photon's behavior. In the absence of which path information, the experiment can yield interference patterns akin to those seen in classical double-slit experiments. However, the duality of information, where one can either observe the path taken or the interference, but not both, underscores the quantum nature of reality. When the which path information is known, the interference pattern disappears. Conversely, if the information is erased, the pattern re-emerges for those instances where the idler photon's path was not determined. The delayed choice aspect of the quantum eraser suggests that the decision to observe which path information or to erase it can be made after the signal photon has been detected. This creates an illusion of retrocausality, where the choice made after the event seems to alter the outcome of that event, challenging classical intuitions about time and causality in physics. The implications of this phenomenon have sparked considerable debate and further investigation within the field of quantum mechanics, revealing the complexities and counterintuitive nature of the quantum world. The delayed choice quantum eraser experiment presents significant implications for our understanding of time, causality, and nature of reality itself. It challenges traditional notions of temporal order and raises questions about the relationship between observation and the behavior of quantum systems. The results of the experiment resonate with the ongoing debate between A theorists and B theorists regarding the nature of time. A theorists argue that time is experienced as a flow or passage where events are classified as past, present, or future based on their temporal location. This perspective suggests that the act of observation can retroactively influence the classification of events, aligning with the findings of the quantum eraser experiment, which indicates that decisions made after a particle has been detected can affect the particle's behavior retrospectively. Conversely, B theorists maintain that time is fundamentally a dimension similar to space, where the distinctions of past, present, and future are relational rather than absolute. They argue that events do not change and that our perception of time's passage is illusory. The implications of a quantum eraser challenge this view by suggesting that the properties of particles can be influenced by later measurements, potentially undermining the B theoretical assertion that events are unchanging once they have occurred. The delayed choice quantum eraser experiment also raises profound questions regarding causality. Traditionally, causality is understood as a linear progression where causes precede their effects. However, the findings from the quantum eraser experiment suggest that this linear relationship may not hold in the quantum realm. Instead, the results indicate a form of non-locality, where information about a particle's state can be altered by future measurements, seemingly allowing for a retroactive influence. This challenges classical intuitions about causation and prompts a re-evaluation of how we understand temporal relationships. Philosophically, the implications of the delayed choice quantum eraser extend into discussions about realism and anti-realism in quantum mechanics. Some interpretations propose that reality is fundamentally indeterminate until it is observed, aligning with an atheoretic view of time, where the act of observation plays a crucial role in defining the state of a system. Others argue for a more deterministic view, suggesting that the outcomes were always potentialities that only manifested upon measurement, which resonates more with a B theoretic perspective. Moreover, the experiment invites further exploration of the implications of personal identity and experience. If the outcome of events can be influenced by later choices, this raises questions about the continuity of self and the nature of decision making. The entanglement of time and observation in quantum mechanics continues to stimulate significant philosophical inquiry, urging us to rethink foundational concepts in both metaphysics and epistemology. Delayed choice experiments are designed to probe the fundamental nature of wave-particle duality in quantum mechanics. The original delayed choice experiment proposed by John Archibald Wheeler in 1978 aim to illustrate how the choice of measurement can retroactively influence the behavior of quantum particles such as photons, demonstrating both wave-like and particle-like characteristics, depending on the experimental setup used at the time of measurement. The first practical demonstration of a delayed choice experiment occurred in 1984 at the University of Maryland, where researchers Carol Alley, Oleg Jakubowicz, and William observed that the choice of whether to measure a photon as a wave or a particle could be made after it had already passed through a beam splitter. This confirmed Wheeler's hypothesis that the behavior of quantum entities could appear to be determined by future measurements. Subsequent refinements by Helmut et al. In 1987 further illustrated the breakdown of classical intuitions in explaining quantum phenomena. With advancements in technology, a variety of implementations have emerged, utilizing not only photons, but also other quantum systems like atoms and neutrons. The experimental setups often involve creating conditions that enable a measurement to occur either as a particle or a wave, depending on the observer's choice at a later time. For instance, researchers have demonstrated the delayed choice quantum eraser, which capitalizes on quantum entanglement to restore interference patterns based on future measurement decisions. Recent experiments have explored concepts like the quantum switch, which investigates indefinite causal orders in quantum mechanics. In these setups, photons can take multiple paths simultaneously, and the final outcomes depend on the order of operations applied to them, suggesting that quantum systems may not follow traditional causal relationships. This research underscores the notion that the measurement can influence the state of a system in ways not limited by conventional temporal constraints. The implications of these experimental realizations extend into the field of quantum computing. Quantum algorithms have been shown to leverage the non-classical processing of information, suggesting that quantum systems can reach into the future for computational advantages. As a result, the study of delayed choice phenomena not only deepens our understanding of quantum mechanics, but also influences practical applications in quantum information science. The delayed choice quantum eraser experiment has sparked significant philosophical and scientific debate regarding the implications of quantum mechanics on our understanding of causality and time. One of the central criticisms arises from the notion of backwards causation, which posits that future choices can affect past events. Critics argue that this notion challenges our conventional understanding of time as a linear progression, leading to perplexing scenarios where causation appears to be reversed. The concept of backwards causation suggests that an event in the future can influence an event in the past, as demonstrated in certain interpretations of the delayed choice experiments. Critics, including proponents of the bilking argument, assert that such claims can lead to contradictions in causal relationships. The Bilkin argument posits that if event A is said to cause event B, one could theoretically create scenarios where A occurs without B, thereby undermining the causal link between the two. This raises the question of whether it is truly possible for future events to have any effect on past occurrences without creating logical inconsistencies. Some metaphysical interpretations propose that the direction of time is intrinsically linked to the asymmetry of causation, wherein past events serve as causes for present and future outcomes. This perspective, while addressing certain phenomena, has been criticized for its circular reasoning and limited explanatory power regarding time asymmetric behaviors that cannot be easily accounted for by causation alone. Additionally, the challenge remains to distinguish between cause and effect in a non-arbitrary manner, further complicating the metaphysical discourse surrounding the nature of time in quantum mechanics. There is ongoing debate about whether the supposed retrocausality observed in quantum mechanics is a genuine phenomenon or a misunderstanding of the experimental results. Some researchers argue that claims of retrocausality stem from misinterpretations of quantum experiments, emphasizing that similar results can be replicated using classical analogs thereby questioning the need to invoke quantum mechanics for an explanation of retrocausality. This perspective suggests that the notion of retrocausality may not be as profound as it appears, calling for a re-evaluation of the implications of the delayed choice quantum eraser experiment on our understanding of time and causation. Very interesting.